Stoich for practice problem 8. We've got 184.12 grams of ethanoic acid. We're going to calculate the number of molecules of ethanoic acid, the number of hydrogen atoms, and the total number of atoms. Given the mass, and we're going to convert to a number of molecules, part A. We've got number of molecules, we've already calculated, and then we can calculate the number of hydrogen atoms from molecules here. And if we have the number of molecules, we can also calculate the number of atoms from that, from the molecule. Stoich roadmap, we would just be using, let me just get this right, yes, we're going to use mass to moles to particles, and of course we'd have a little particles to particles bit too. Just stick that over there. So to start with, we've got the mass of ethanoic acid, and we're going to use the molar mass to convert to moles. The molar mass of the ethanoic acid is 60.06 grams per mole. So the conversion factor we'd use is 1 mole over 60.06. And then we want to calculate the number of molecules. So we use Avogadro's constant. And we know that 1 mole of ethanoic acid is 6.02 times 10 to the 23 molecules of ethanoic acid. Conversion factor would be Avogadro's constant over 1 mole. Put it in, and you do the math. And you get 1.85 times 10 to the 24. And we've got 3 sig figs, and we use Avogadro's constant to 3 sig figs, so we'll keep it like that. The number of hydrogen atoms, we know we have this many molecules, and we know that ethanoic acid has 4 hydrogen atoms, and so 1 molecule has 4 hydrogen atoms. Conversion factor would be 4 hydrogen atoms over 1 molecule. The hydrogen atoms goes on top in the conversion factor because it's what we want to find. It gives us 7.38 times 10 to the 24 atoms. And we keep the 3 sig figs because that's what we used from our last question. And we do the same thing again. We know that ethanoic acid has 1, 2, 3, 4, 5, 6, 7, 8 atoms altogether. So 1 molecule has 8 atoms. The conversion factor would be 8 atoms over 1 molecule. Stick it in, do the math, and we get 1.48 times 10 to the 25. And we would again stick with 3 sig figs because that's what we used as our to do the calculation. Question 9. We've got number of atoms, and what do we want? We are converting to a number of moles, and then from number of moles we can go to mass. So atoms to moles to mass. The number of formula units, question B, of calcium chloride in micrograms. So this time it doesn't want us to calculate it in grams, but in micrograms. We know we have 1.2 times 10 to the 17 formula units. So we can convert number of formula units to moles, and then convert the moles to mass in grams, and then convert the mass in grams to the mass in micrograms. The Stoich roadmap, what we're going to use, we're going to use mass to moles to number of particles, going between mass and number of particles. There'll be a bit extra here because we're going from mass in grams to mass in micrograms. So we've got 3.01 times 10 to the 25 atoms of manganese. We're going to use Avogadro's constant in the conversion factor. 1 mole has 6.02 times 23 atoms. Moles goes on top. That's what we want to convert to. And then we use the molar mass of manganese to convert into grams. The molar mass is 54.94 grams per mole. So the conversion factor would be 54.94 grams over 1 mole. Grams is on top, because that's what we want. And we get 2.75 times 10 to the 3 grams. And we've got 3 sig figs, because that's what we've got in the question. Next, we've got 1.2 times 10 to the 17 formula units of calcium chloride. We know that the 6.02 times 23 formula units of calcium chloride in 1 mole of calcium chloride. So the conversion factor would be 1 mole over 6.02 times 10 to the 23 formula units. And we need to convert to moles, so moles goes on top. The molar mass of calcium chloride is 110.98 grams. Would use molar mass to convert moles to mass in grams. Conversion factor 110.98 grams over 1 mole. Grams goes on top because it's what we want to find. Next, we're going to convert to micrograms. We know that 1 gram equals 10 to the power of 6 micrograms. And conversion factor would have 10 to 6 micrograms over 1 gram. Microgram goes on top because it's what we want. Cancel those units out, do the maths. We've got 22 micrograms. We've got 2 sig figs because that's what we have in the question.